Hello, fourth graders. Welcome to another day of e-learning and another day of fractions. Today, we will be working on this lesson 6 problem set, and it pretty much just builds upon what we did yesterday and last week. We are looking at area models, and we are decomposing them to figure out other ways we can write these fractions or other ways we can express these fractions. I know that this looks pretty scary right now, right? But we're going to work through it and it'll totally make sense. So, first things first, we'll start with number 1. Each rectangle represents 1. So this entire figure represents 1. Draw horizontal lines to decompose each rectangle into the fraction unit as indicated. Use the model to give the shaded area as a sum and as a product of unit fractions. So that's what they're doing over here. Use parentheses to show the relationship between the number sentences, and the first one has partially been done for you. So I'm going to rewrite this area model again just so it's easier to see. So we started off, we know that this entire figure is equal to 1. So that means I know that each of my unit fractions is 1/3 or 1/3. My denominator would be 3 because there's a total of 3 boxes that are coming together to make this figure. And I also know that I'm going to shade in 2 boxes. Why do I know that? Well, it's given to us, and we know that we need to represent 2/3 or 2/3. Okay, and they are telling us that we need to divide this into sixths. So that means we should end up with 6 total boxes. So what we're going to do is we're going to take a horizontal line and just cut it down the middle. How many boxes do we have now? Well, let's count. 1, 2, 3, 4, 5, 6. We have 6 boxes now, so that means we divided this figure into sixths. So my unit fractions now will be what? Yeah, exactly. So 1/6 or 1/6. How do I know that again? Well, that's just simply because there's now 6 total boxes, and the unit fraction is just the total boxes is the denominator, and 1 will be our numerator because each box represents just one piece in this figure. So I have 1/6, 1/6, 1/6, and 1/6. Okay? And they're asking us to rewrite now 2/3 into different ways. So we could say 2/3 is equal to what? Well, we could say 2/3 is equal to 1/6 plus 1/6 plus 1/6 plus 1/6. Let's add this fraction. 1, 2, 3, 4. So I know that 2/3 is equal to 4/6. Okay, that's what we just did. 2/3. So this original 2/3 is equal to 1, 2, 3, 4, 4/6. Let's break this down further. What could 1/3 equal? If we're just looking at this, and we know that this box is 1/3, we could say that 1/3 is equal to 1/6 plus 1/6. And that's what they got at right here. 1/3 is essentially just equal to 1/6 plus 1/6. 1/3 is equal to 1/6 plus 1/6. And that still equals 4/6. Let's look over here again. How can we write this into a multiplication sentence? Okay. we can write this into a multiplication sentence by, we could, for one, say 2/3 is equal to 4 times our unit fraction, which is 1/6, right? Or we can also say, here, right here, 2/3 is equal to 4 times 1/6, which is equal to 4 sixes. What else can we say? We could say 1/6. So I want you guys to try B on your own to divide this into tenths. So I'm going to set this up for you by drawing this horizontal line to divide this into tenths. Okay, so now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal boxes. Same thing for C. Instead of this time, we need to make sure we have 12 equal boxes. So how can we do that? Okay, so you need to draw horizontal lines to divvy this up into 12 equal boxes. And for 2, let's work through one of these together. So draw an area model to show the decomposition represented by the number sentences. Express each sum. Each is a sum and a product of unit fractions. So that's pretty much what we already did up here. Okay. 1/6, yep. Okay. So first things first, let's represent this 3/5. So I know I'm going to need to have 5 equal boxes. 1, 2, 3, 4, 5. Each unit fraction now is 1/5 or 1/5. And how many are shaded? 3 are shaded. 1, 2, 3. Okay. And I need to now have 10 equal boxes because my new denominator is 10, so I need to have 10 equal boxes. So I'm going to take my horizontal line and divide it right down the middle. And now I have 10 equal boxes. And my unit fraction then would be 1/10, 1/10, 1/10, 1/10, 1/10, and 1/10. Now, did we just prove that 3/5 is equal to 6/10? Yes, we did. Why? Because now we have 6 boxes that are shaded. 1, 2, 3, 4, 5, 6. So let's try to follow these guidelines and write this number like this. Okay, so we have 3/5 is equal to 6/10. We can also say that 3/5, we could say that 3/5 originally was equal to 1/5 plus 1/5 plus 1/5. We could now also say that 3/5 is equal to 1/10 plus 1/10 plus 1/10 plus 1/10, I'm running out of room, plus 1/10 plus 1/10. And how did we get that? Well, we just simply now added all of these together. 3/5 is equal to 1/10 plus 1/10 plus 1/10 plus 1/10 plus 1/10 plus 1/10. How can we rewrite this as a number sentence? We could say 3/5 is equal to how many boxes do we have that are shaded? 1, 2, 3, 4, 5, 6 times our unit fraction, which is 1/10. Okay. You could break that up in more ways, but for now, let's just focus on this multiplication sentence and then this number sentence, okay? So go ahead and try B right now on your own.